Hello everyone. Today we'll discuss about validation based protocols. This is also known as optimistic concurrency control. These are the set of techniques that aim on increasing the system concurrency and performance by assuming that conflicts between transactions will be rare. Optimistic, you have seen this even in your operating system concept. I assume that deadlock will not happen, right? So that when it happens, let us see, because it is very, so similar thing. So instead of preventing the conflict through locking or timestamp, what it does is, it will validate the transaction at the time of commit just to check whether it has conflicted with any of the other transaction. If so, it will just abort and restart it. So remember, in optimistic concurrency control, the basic premise is that most of the transaction will not conflict with other transactions. So the idea is to be as permissive as possible, allowing the transaction to execute. You let them execute. Before just committing, just check whether it has conflicted. If yes, you abort, otherwise you proceed. So it divides it into three different phases. First one is a read phase, where the transaction executes reading values from the database and writing them into its private space. Okay, it never updates the database but into the private. Validation phase is one when it decides that it has completed and it wants to commit. So before committing, DBMS checks whether this particular transaction could possibly would have conflicted with any other concurrently running transaction based on certain rules. So if there is no possible conflict, the transaction is aborted. Okay, if there is possible conflict, the transaction is aborted and the private workspace is cleared and it is restarted. But if there is no conflict, then the write phase. If the validation determines that there is no conflict, then the changes to the database data objects are made from this private workspace as the permanent one. It is atomicity what we have seen. It will make these changes permanent. Okay. Now comes to the validation criteria and the rules. Criteria is based on timestamp ordering. What it sees is it should be in serial order. So you have seen in your timestamp based protocols that each transaction is assigned a timestamp when it starts. The validation ensures that the transactions operations can be serialized in the order of their timestamps. Main idea is this. So if you see, to validate TJ, we must first check and see to that one of these conditions what we mention here is holds with respect to each committed transaction, and TI is completed before TJ, or transaction TI is occurred before TJ in the time of entering this particular thing. Now let us see what are those rules. Rule number 1 says, for two transactions TI and TJ, where TI completes all its phases before TJ starts in the serial order itself, no validation is needed since they don't overlap. So TI completed everything before TJ started. So that means it allows TJ to see TI's changes, but clearly they execute completely in serial order with respect to each other. So no issues at all. Coming to the second condition, the second rule says, if TI overlaps with TJ and TI precedes TJ in validation order. In the timestamp order, when you see, if TI is before TJ, TJ's read set must not intersect with TI's write set. That means anything that TI has updated, TJ should not read. If that is the case, there will not be any conflict. You need not restart. Na? See, TI completes before TJ starts its write phase. So TI does not write any database object that is read by TJ, or vice versa. TJ will not read any database object that is written by TI. Then in that case, there is no need of changes. See, this condition allows TJ to read the objects while TI is still modifying, but there is no conflict because TJ does not read any object modified by TI. So although TJ might overwrite some of the objects written by TI, no problem, but TJ will not read any item which is modified by TI Tj will not read, modified by Ti. That means uncommitted reads will not be there. So that is why you can be guaranteed that there won't be any conflict. So this rule holds also, you continue, it is validation, validated. The rule number 3 says Ti and Tj overlap and Tj precedes Ti in the validation order. Then in that case, Ti's write set must not intersect with the Tj's read and write. So you should not read or write anything that has been updated or that will be updated by Ti, that is future. So Ti completes its read phase before Tj completes its read phase. Okay, and Ti does not write any database object that is either read or written by Tj. Tj has completed or Tj has finished. Okay. So it will not read. So this condition allows Ti and Tj to write objects at the same time. But even more overlapping will be there, but sets of objects written by the two transactions will not be the same. What they write is not the same, or what one has written is not read by the other one. If that is the case, I can be assured now there won't be any conflict. So read write or write or write read is not there at all. So if these three conditions are satisfied, or if any of these conditions satisfy, I see to that there is no conflict. So I can go ahead, I can write it. Because in most of we are looking for this kind of situation in such application where we expect the conflicts to be less. Okay. So example scenario is again conflicting and non-conflicting. We can see that if they are having the same data objects, look at this, T1 reads A and B and writes B, T2 reads B and C and writes C. So if you see writes B and here it reads B, so there is a conflict. So this is going to be a conflicting transaction, whereas if you see the first case, T1 reads data items A and B and writes B, T2 reads data items C and B and writes D. Two different sets data items, so non-conflict. So there is no conflict there, there is a conflict here because of the common data. That is where we say it should not intersect. Okay, coming to the advantages, there can be increased concurrency. You can proceed without waiting for the lock, acceptance of the lock, lock being granted, all these things are not there, releasing is not there. So parallelism, increased concurrency, reduced deadlocks because we ensure serial order, the risk of deadlocks is minimized. Simplicity is, it is very easy to, simpler to implement for reading, mostly workloads where conflicts are rare. So in situations where conflicts are rare only you can go with this. So it is very simple to maintain also. Disadvantages would be high overhead. So in case if you assume that there won't be conflict, but in case if you see that in a particular situation there were conflicts, then in such situation you see that rolling back, maybe certain transaction has to be rolled back again and again whenever the validation fails, and restarting them will be costlier. So this is high overhead. Resource intensive, maintaining read and write sets, performing validation checks require additional resources. So you have to maintain that. We have said that read set, write set should not overlap and not suitable for high conflict workloads. In situations or environment where frequent conflicts are there, overhead of rollbacks is going to be very much as compared to its simplicity. So you cannot go with such kind of optimistic concurrency control protocol, or otherwise the validation based protocol. It is suitable only for the situation where the expected conflicts are going to be very less. Okay, thank you. We'll proceed with log based recovery scheme in our next lecture.